Our next segment is going to be on broadcast versus collision domains. So what are broadcast domains and what are collision domains? Well, a broadcast domain is an area of our network where a broadcast message can reach. So these are all the devices in a certain area of our network that can be reached at layer 2. We could hypothetically reach them just by their MAC address. If we send out a broadcast message, or if those devices try to send out say a DHCP discover message without having an IP address assigned to them, we would be seeing those packets on another device in that same broadcast domain. Essentially, a broadcast domain is going to be anywhere that a link does not pass through a router. Routers will not pass on layer 2, just layer 2 only communications. In order to pass through a router, you have to have layer 3 communications. You have to have IP addressing. So broadcast domains are going to be where, if we were to broadcast from a certain computer, those broadcasts would reach, and it's not going to pass routers. Collision domains, on the other hand, are going to be devices, or they're going to be areas of our network that if two devices or more than one device were to talk at the same time, it would create data collisions. So these are going to be on links between devices, so on cables that directly connect two devices, and it's also going to be on devices connected to a hub. Because remember, hubs do not inspect traffic, and they don't not forward traffic just because someone doesn't have a certain MAC address. If you connect into a hub, you're going to be receiving all the data that's sent to that hub by other computers or anyone else connected to that computer. Hubs are dumb. Hubs are just going to push out the message to everybody. So hubs create devices connected to a hub are in a collision domain, because if anyone talks that's connected to that hub, everyone's going to get that data. And if any of those other computers are trying to talk at the same time that the hub is sending them data, it's going to cause a collision on that link. So we need to understand how broadcast domains and how collision domains work. So the best way to understand that is to take a look at our diagram here. So our diagram here has a couple of different components. We have our hub. We have multiple switches, SW, SW, SW. We have our router, we have our bridge, and a second bridge. And the connections between our different devices are indicated by a black line. So let's take a look at our our broadcast domains first. So our broadcast domains are going to be all the areas that are on the same side of a router. So say if computer A here sent out a broadcast message, who all would hear that message? Well, let's take it one device at a time. So we travel down. Is this hub going to forward on a broadcast message? Yes, this hub is going to just send messages to whoever it receives from. So it sends that broadcast message to our computer over here. We're going to label it computer B. It's going to send that message on to our switch. Is our switch going to send on a broadcast? Yes, a switch is going to send on a broadcast. So it's going to send it on to computer C, computer D. And our switch sends it on to a bridge. Now will our bridge forward on a broadcast? Yes. So we have computer E and computer F. Computer E is going to receive that. The bridge will also forward it on to our second bridge, who will forward it on to computer F. And our bridge will also forward it on to computer G. Now, what about our router here? If our switch sends that broadcast message to our router, will our router forward it on? No, because routers will only address packets that are directly sent to them. They will not address or forward on broadcast messages, and it's very good that they don't, because our routers, if they forwarded on broadcast messages, that'd be a really big mess. So our routers aren't going to forward on broadcast messages, so that means that the router will receive the broadcast message, but it's not going to forward it on to anyone else. So that means that our broadcast domain for all of our computers over here is all of this. That's it. That's our broadcast domain for over here. So that means that all of the devices which I've circled are all in the same broadcast domain. So what about these devices over here? Do they have a broadcast domain? Yes, they have their own broadcast domains. Computer, what letter are we on? H. Computer H, if it sends out a broadcast message, it's going to include the computer, the switch, and the router. So yes, our router can be in multiple broadcast domains. And then finally, computer I is going to send out a broadcast message, and it's going to get to the switch and the router. So in our network diagram here, we have 3 separate broadcast domains. Okay? All of our devices, our hubs, our switch, our routers, are all going to forward broadcast messages, and the only one on our diagram that is not going to forward a broadcast message is going to be our routers. So let's go ahead and give ourselves a little bit more room so we understand our broadcast domains. We'll erase our 2 smaller broadcast domains here and leave our one very large broadcast domain. So we have our broadcast domain over here. Now what about our collision domains? Now our collision domains are going to be on links and they're going to be on hubs. So starting again with computer A. Computer A sends out a standard packet. It sends out a direct packet. We're not talking about broadcast packets here. We're talking about a direct packet. It doesn't matter to who. We're just talking about the next step. Are we going to have a collision domain? So computer A is going to send a packet directly to our hub. Because our hub is on link, it's directly connected to A, that we automatically know that that's a collision domain. Because our hub in our computer A, if computer A is trying to talk at the same time as our hub, there's going to be a collision. There's going to be some data collision. But because it's a hub, our hub is also going to forward that packet to anyone who's connected to it. So if computer A is trying to talk to, it sends a packet to our hub, at the same time computer B is trying to send data to our hub, then there's going to be some collisions going on because our hub is going to send the data to everyone, even if computer A is just trying to send a packet over to computer E over here. So our computer A, our computer B, our hub, and our switch are all in one collision domain thanks to our hub here. So that's one collision domain. Our switches do not create as large collision domains as hubs because our switches actually create, they have tables in which they assign certain ports to certain MAC addresses. So if computer C is trying to send a packet directly to computer E, the only on-link device that it has is our switch. And our switch isn't going to just broadcast that packet out to everybody like our hub does. It's going to directly send it. So our only collision domain between our computer C and our switch is this on-link right here. If computer C and our switch are trying to talk to each other at the same time, there's going to be a collision. But our switch isn't going to act like a hub and send it out to everybody, so there's no additional collisions after that. The same between computer D and our switch. Single on-link collision domain. Between our switch and our router, we have a single on-link collision domain. Between our switch and our bridge, we have a single on-link collision domain. But what about between E and our bridge? Well, our bridges act similar to our switches in which they connect different components of our network. Our bridges over time will begin to take analysis of information, and they'll say, okay, they aren't just going to broadcast data that's sent to them like hubs do. Our bridges are going to connect different network segments, and E is sending a packet to D, so our bridge isn't going to send that packet to everybody. It's just going to send it where it needs to go. So on our bridges, our only collision domains are our on-link or our directly connected devices. The same with our bridge over here, our connection to bridge over here, our router connection here, our switch, and finally our last device there. So we see if we eliminated this hub from our network, we would have very small collision domains. Pretty much only the devices that were on link to other devices would be our collision domain. So our broadcast domains, again, in recap, broadcast versus collision domain. Broadcast domains are going to be a domain where a broadcast message will reach whoever. If a single computer on a network segment sends out a broadcast domain or a broadcast packet, who will get that packet? And that includes everyone on their side or on their link of a router. A router will not forward a broadcast packet. A router will not pass it on. And then collision domains are going to be if two devices are talking simultaneously, will there be a collision of data? Hubs create larger collision domains because they forward packets to everybody. If computer A is talking at the same time as the switch, that data is going to get to the switch, and then there's going to be collisions as they're trying to talk between. If computer A was talking to computer E, and computer B was trying to talk to computer D, there would be collisions there because our hub is just going to send that data out to everybody. The packet that computer A meant to go to computer D is also going to go to computer B. So if computer B says, well, let me try to talk right now. Nope, you can't, because computer A is talking right now. And there's data coming down this link, and as well as this link and this link, because that hub is there. But our collision domains can be shrunk, we can mitigate some of those or shrink and isolate some of those by removing hubs and replacing them with switches and our bridges. So that's our difference between our broadcast domains and our collision domains.